Keep it saying hello.
Okay, well, they may have just gotten you saying whatever it is that you just said, but that's okay. Yep. Hello, everyone. Third period says hello. This is their class. All right, so we're solving systems of nonlinear equations, meaning what values of x and y satisfy both of these equations. So think back to, like, algebra 1, even algebra 2 earlier this year when we solved the system. You have three main solution options. You could solve this by substitution, you can solve this by elimination, or you can solve it by graphing. Algebraically is what we're going to focus on right now. Personally, elimination is my favorite. I just think it's a little bit easier. However, notice, in order for you to eliminate something, you have to have the same variables with the same degrees. Sam, Michael, focus. The same variables with the same degrees, and they have to have the same coefficients. Well, this poses a big problem because we don't have.
Yes. Can you please send offshore overhead down like that? He's checking out. You don't have
Well, this is a hot mess for my video. He's in fourth period here.
I don't know.
Okay, maybe they left already. Anyway, so we can't eliminate this because we don't have any matching terms. So in order for you to eliminate something, all your stuff has to be matching. So we're going to go ahead and try substitution instead. So I'm going to go ahead and rewrite my first equation. Instead of xy equals 2, when you substitute, you just want to solve one of your equations for one of the variables. So I'm going to solve mine for y. Y is equal to 2 over x. You could solve it for x if you wanted to be the same thing. X would just equal 2 over y. And then the goal is, once you isolate one of your variables, then you take that and you substitute it into the other equation. Okay, so then we get, for the second equation, instead of x squared equals 3 plus y squared, we get x squared equals 3 plus, we're substituting in a new version of y, which is 2 over x, and then squared. So that's the substitution part. Then your goal is to solve for x, figure out which values of x make this true. So let's go ahead and kind of simplify this out. So we'll get x squared equals 3 plus 2 over x squared is 2 over x times 2 over x, which is 4 over x squared. So this poses a little bit of a challenge because 4 over x squared is technically a negative exponent, right? It's actually 4 times x to the negative second power. So it can complicate things a little bit. So what you're going to do if you ever have this scenario is, let's go ahead and get rid of our fractions. So in order for me to get rid of the fractions, I want to multiply by whatever my denominator is so that it cancels. Okay, so we're going to distribute this x squared to all three of our terms. So x squared times x squared is x to the fourth equals 3x squared plus, when you multiply the last term, it cancels out the denominator x squared and just leaves us with 4. Okay, so now you're like, well, Ms. Schweiner, what the heck? Now we have x to the fourth power. Like, how the heck are we going to solve that? Well, then what you're going to do is move everything to one side. So if I have x to the fourth power minus 3x squared minus 4 equals 0. Do you see how this kind of looks like a quadratic equation? Right? Quadratic equations are in the form ax squared plus bx plus c equals 0. So this is very, very close to that, except instead of x squared and x, I have x to the fourth and x squared. So then here's kind of a new concept. We're going to suppose that u, another variable I'm defining, is equal to x squared. So if I can rewrite my x's with these weird exponents on them, I might be able to get this into a quadratic equation that I do know how to solve. So let's do that. If x squared is the same thing as u, then what is x to the fourth power in terms of u? u squared. So instead of x to the fourth, that's the same thing as u squared, minus, instead of 3x squared is u, so this would be minus 3u minus 4 is equal to 0. Now, this does look just like a quadratic equation that you can factor. What two numbers multiply to be negative 4 and add to be negative 3?
-4 and 1.
Okay, so u minus 4 times u plus 1 is equal to 0. And this is true when u is equal to 4 and u is equal to negative 1. Now, you can't just forget like what we did earlier, where we did this. It's called u substitution. You'll use this a lot in calculus. You can't just neglect that and say, oh, we straight up changed our stuff. So now you go back to what you defined u as. If you said that u is equal to x squared, then you have to resubstitute back in order to get your stuff back in terms of x's. Okay, so if u is the same thing as x squared, then that means instead of u, this means x squared is equal to 4. And instead of u equals negative 1, x squared equals negative 1. Okay, if x squared is equal to 4, then what does x equal? And 2 and negative 2. Anytime you take the square root of something, you have to include the negative option. And then if x squared is equal to negative 1, when you take the square root of both sides, you end up with an imaginary number, which means you cannot proceed with that solution because you're not going to get a real solution. So your first answers, well, the first part of your answers, are if x is equal to 2 and x is equal to negative 2. So remember, in order to find a solution, you have to figure out the ordered pairs that make it true. So you're going to take your two possibilities for x. So we'll say, okay, if x is equal to positive 2, then you're going to plug positive 2 into either of your original equations. I'm going to plug it in the first one because it just looks easier. So 2 times y is equal to 2 implies that y must equal 1. So when I plug in 2, I get y is equal to 1. So that's my first answer, 2 comma 1. And if x is equal to negative 2, then negative 2 times y is equal to 2, which when you solve this for y, that implies that y must equal negative 1. So when I plug in negative 2, we get out negative 1. So these two are the answers. Now, going forward, I need you to understand that not every system of equations is going to have two answers. Okay? Some may have no solution, some may have 1 or 3 or 4. Why is that? I want you to think about what we're doing. Can have 0, 1, 2, 3, or 4 solutions. Think about the kind of stuff that we're graphing. What does the graph of xy equals 2 make? Xy equals 2. If I solve that for y, if I have xy equals 2, if I solve this for y, I get y equals 2 over x. That's a rational equation. So that's what gives us, remember we did this a few months ago, where you have the curves in the first and the third quadrants like that? And then x squared equals 3 plus y squared. If I kind of rearrange that and get everything to one side, then I get x squared minus y squared is equal to 3. Which conic section has a positive, one's a positive and one's a negative? Hyperbola. So think about this. Think about all the ways that a rational equation can intersect with a hyperbola. I can have it like this, which is probably what we have going on here, where there's two intersections, right? Or I can have it to where our rational equation is in the first and the third quadrant, but maybe the hyperbola is way down here, which means it might intersect twice, but in these directions. And then depending on where the asymptotes are, could it intersect it even more. Other things that we're going to be intersecting are like a circle with a circle with an ellipse. How many answers can that one have? It can have 2, it can have 0, it can have 1 if it's just touching it, right? I can have 2 ellipses intersect each other like this to where they intersect 4 times. Okay, so the hard part is there's not a clear cut and dry answer to how many solutions you're going to get every single time. It depends what conic sections are intersecting and where they are how they're intersecting. Okay, so that's kind of visually what's going on. I've got one more algebraic example for you though. We're going to solve x squared plus 2y squared equals 9, and 3x squared minus y squared is equal to 1. Okay, so this is an example where we can go ahead and use elimination because I have x squareds and y squareds. So you can do a couple different things. You can either multiply your top equation by -3, or you can multiply your bottom equation by 2, which is what I'm going to choose to do. So then if we do that, I get x squared plus 2y squared equals 9. The first equation remains the same. The bottom equation, when I multiply it by 2, is 6x squared minus 2y squared is equal to 2. So then when I add these together, x squared plus 6x squared is 7x squared. 2y squared minus 2y squared cancels, and that's equal to 11. Any questions so far on the elimination process? Okay, when we solve for x, you get x squared equals 11/7, which are not square numbers. So when you take the square root of both sides, this implies that x is equal to plus or minus the square root of 11/7, which I'm going to give you permission on this one. And whenever necessary, anytime you have radicals like this at the very end, you can go ahead and give this to me as a decimal approximation to the nearest hundredth. So that one's going to be about plus or minus 1.25. There's only one like this on your study guide where you get decimals. Now, x could be positive or negative 1.25. So you have to go figure out what the y variables are going to be. So you need to substitute this back into one of your original equations. Now, I recommend you not substituting in the approximation, actually substitute in square root of 11/7. I'm going to do it to the first equation. So square root of 11/7 squared plus 2y squared equals 9. And then you're just going to simplify this to figure out what variables of y make this true. Square root of 11/7 squared is just going to be 11/7. Plus 2y squared is equal to 9. And then we got to isolate y. So we're going to subtract 11/7 from both sides. Now, remember, you can't use a graphing calculator on your test. So if you rely heavily on the graphing calculator to subtract fractions, make sure you practice those skills without a calculator. If I'm going to subtract 9 minus 11/7, I can go ahead and multiply 9 by 7/7 to have common denominators, which will be 63/7 minus 11/7. So then I get 2y squared is equal to 63 minus 11 is 52/7. And then to isolate y squared, I need to either divide both sides by 2, or it's the same thing as multiplying by 1/2. Which, since I have a fraction on the other side, that's going to be how I want to think about it. So then I get y squared is equal to 52 over 14, which can be reduced to 26 over 7. So then I get y is equal to, anytime you take the square root, it's plus or minus the square root of 26 over 7. Again, not square numbers, so you'll have permission to round to the nearest hundredth, which will be plus or minus 1.93. So you have a positive and negative option for x, and you have a positive and negative option for y. So how many possible answers do you have for the system? Well, yeah, 4, let's see. So remember 1.25, both of them could be positive, like this. Both of them could be negative, negative 1.25. Holy shnikes. Did y'all hear that? This is what y'all will have in a few hours. I feel like in danger sitting next to this window with my laptop plugged in. So let me unplug these. So these 4 are our answers. Okay, and that's how you do it algebraically. The last one we want to cover is graphically. And this one's actually going to be a system of inequalities. X squared plus y squared is less than or equal to 36. X plus y squared is greater than 0. So anytime that you're solving a system of inequalities, it's going to involve some shading. So you're going to choose a test point, figure out what side to shade on, that kind of stuff. Okay, so the first inequality, x squared plus y squared is less than or equal to 36. What is that going to create? What conic section is that? It is a lovely looking circle because there's no shift. So its center point, because there's no x minus h or y minus k, the center point's just at 0, 0, and the radius is equal to 6. So go ahead and graph that circle. Now, what's going to be kind of weird, and in this case for the circle, it's fine, but just like when we graph linear inequalities, if you don't have a greater than or equal to or less than or equal to, you have to put a dashed line. Okay, the same is going to be true with conics. So because we have a less than or equal to, we can go ahead and make a solid circle like this, but if that just said less than, you would have to make your circle with dashes. And then after you graph it, we're going to have to figure out where to shade. So you can go ahead and choose a test point. Again, a test point that's not on the graph. Now, the center point is technically not a part of the circle. The circle is defined as the set of all points that are equidistant from that center point. So I can still test 0, 0 if I want. So when I test 0, 0, I get 0 squared plus 0 squared, which is 0, as less than or equal to 36, which is true. So if that is true, do I shade on the inside or outside of the circle? Inside. So I'm going to save the shading until last because I want to shade where they're going to overlap each other. Okay, so we'll shade on the inside of the circle. X squared plus y squared is greater than 0. What is that going to make? You only have one squared term. A parabola, very good. So if I have y squared is greater than, I'm going to move x to the other side because parabolas, we like to have the squared term isolated and then everything else on the other side. So if that's the case, again, just like our circle, the center point of this is 0, 0 because there's no binomials with the x and the y showing that they've shifted. Okay, so our center point is going to overlap the circle center point. This is where you have to just be careful in graphing this stuff. If I have y squared, which direction is my parabola going to face? It's not going to be up. There are two things to consider. I have y is squared, and 4p is always the coefficient of the other stuff, and that's negative. So if I have y squared and I have a negative p, which direction will this face? Left. Thank you. Left. Okay, so if that's going to face left, then when I find, remember, I don't care about other specific points on that parabola except the focus. I want to know where the focus and the directrix are. Okay, in order for you to find the focus, you're going to take, instead of your h and k, you're going to take h minus p, comma k. Well, h and k are already 0, so you just need to figure out what p is. Well, what is 4p? 4p is the stuff in front of your non-squared term. Yeah, very good. So if 4p is negative 1, then that implies p is negative 1/4. So if p is negative 1/4, then that means my focus is 0 minus, well, I'm sorry, it's h plus p. I was thinking ahead because I knew it was going to be a negative number already. It's going to be h plus p. So if it's h plus negative 1/4, then that means the focus is at negative 1/4, comma 0. Now, it's going to be, my graph especially is really, really small, just to make the focus as close as you can without getting to 1. Always label your focus with F, or if there are 2 foci, do F1, F2. And then the directrix, hopefully you're getting pretty good at this, the directrix is just going to be on the other side of the focus in that same distance. So if the focus is 1/4 distance away on the left side, our directrix is going to be 1/4 the distance away on the right side, which is the equation x equals 1/4. And then the axis of symmetry goes through the focus and the vertex, which is the equation y equals 0. So for parabolas, I think they're the most challenging to graph, honestly, especially quickly, because you have to find the focus and the directrix. And then once you find those, I'm okay with you estimating the curve. Now, this is a greater than symbol. So if it's just greater than, that's where you need to go ahead and also make sure that your parabola is dashed. And then just like we did for the circle, we're going to choose a test point. Now, you cannot choose 0, 0 because 0, 0 is the vertex of the parabola. Oh yeah, I said center, but I should relabel that V for vertex. Yeah, okay, so you could do negative 1, 0, sure. So if you test negative 1, 0, then you get negative 1 plus 0 is greater than 0. Is that true? Is negative 1 greater than 0? So if that's false, where do you shade? So you're going to shade on the opposite side of where negative 1, 0 is. For the parabola, it would be the outside. So we need to shade on the outside of the parabola, but on the inside of the circle. So the place where those two double up will be this part here.